Good day. We are here today to present our applied machine learning solution to your credit card fraud detection problem. I'm accompanied by my group members, Ashley Brown, a senior business analyst with SHS, Deidre Collier, a credit review analyst with Bank of the Ozarks, and Joshua Kraus, myself, an operations research officer with the U.S. Army. Here is our agenda for today's presentation. I will be followed by Deidre Collier to discuss your organization's problem statement.
There has been issues with fraud occurring during some of the online purchases for Branson Strip performances. This issue has increased for the company year over year. With the increase, there has been several problems to arise. One would be the consumer's confidence in Branson on the web application. Consumers worry about their sensitive information being compromised. Another issue would be the increase in credit-related fees, which can be unexpected expenses, which can lead into creating cash flow issues. Last of the problems would be the time that it consumes to asset management, which would be time spent effectively elsewhere. We have researched and found that the average for fraudulent ticket sales are at $50. There are even some instances where this is hit up to $150 around peak show times. With this, we have found that this is well above the norm for this industry, and the 5% decrease in year-over-year sales target. So let's get into our project team introduction. A little information about ourselves. As I stated, we are Team Classification, which is an external consulting group. We are knowledgeable in machine learning and have used it in various scenarios. We have also created prediction models for an extensive group of people in various industries, such as housing, marketing, as well as transportation. Now, our goal is to provide tailored machine learning applications, training, and analytical services that enable end users to utilize our solutions to make confident predictions within our organization. So now we're moving into our project scope. So the scope of the project has several points that we wanted to achieve in this project. The first being is to develop a machine learning system that can predict over 99% accuracy in identifying credit fraud transactions on the Branson on the Web application. Now, we would also have to look at other fraud solutions and guidelines that are used by other credit institutions in Branson. And last, we want to make sure that we bring awareness to this newly developed fraud detecting system for the Branson on the Web application. We also do have some scope exclusions, and that is the actual implementation of our recommended solution. Now, however, a follow-up project could help implement the solution. And with the follow-up project, we would suggest that you use the actual recommended technology, as well as develop a maintenance, training, and support that could be used across the board.
Thank you, Deidre. At this time, I'm briefly going to discuss why you need predictive analytics and machine learning and what our proposed solution is for your company. You need predictive analytics because it's going to help improve your business outcomes and processes. It will do this by helping to enhance your decision making and will help you optimize and automate your decisions. Machine learning is the applications and the algorithms that is used to run those predictive analytics. And by having machine learning, it can lead to diverse company-wide strategies that will help you succeed faster and generate more profitability for your company. Our proposed solution for you falls in the family of classification modeling. The process that we chose is called gradient boosted trees, and the reason we chose this is because we are going to be predicting class labels as an output, or in other words, we're going to be predicting, is this a case of fraud or is it not? And that is what classification models are very good at doing. On the previous slide, I briefly went over why companies are using predictive analytics, but I wanted to go into some more detail on what areas predictive analytics can help with. One of these areas is potential new market opportunities and markets to invest in for the future. Another area that predictive analytics can help with is by identifying new consumers, as well as how to target these consumers, what time of day or time of year to make contact, and what messages should be communicated to these new consumers. There are some impact on managers' jobs when it comes to the use of predictive analytics, and the biggest one being that there will be less experience required for making decisions because information will be coming so much faster for these managers. This is important because this availability of information can allow managers to spend more time planning instead of putting out small fires every day, because they will be alerted to potential opportunities or threats in the future well in advance. We now know the benefits of using predictive analytics, but to get the most out of your predictive analytics, you should be utilizing machine learning. Machine learning is the needed algorithms and applications that help to bring greater predictive accuracy to your predictive analytics models. Machine learning can assist with this through continually learning and refining the models to generate better predictions. This is done as the machine learning application continues to get more data. It learns from its mistakes in the past so that it will not make those same mistakes again, and is continually optimizing. Machine learning applications can also quickly consume and update data and models. Machine learning applications also can handle large data sets of both structured, such as a consumer database or customer database, and unstructured data, such as a social website post. And the last thing that machine learning can help with is that it can scale across several different business functions, so it does not have to apply to just one area of the business. Now that we know the benefits of machine learning, it is easy to see how this could be used for credit card fraud detection. Machine learning algorithms will assist with fraud predictions by processing transactions in real time. The machine learning algorithm will learn the patterns of the cardholders and be able to determine if a charge is fraudulent based on if that purchase is out of the ordinary for that customer. Machine learning algorithms will also be able to process more information faster than a human ever could, and this will make the fraud detection cycle quicker. Also, with the nature of always updating the algorithms with new data, the machine learning algorithms will be able to detect new fraud techniques and adjust accordingly to those new techniques. The last thing that the machine learning algorithm will be able to do is aid in the improvement of accuracy, so there will be less false negative results.
Our model's training data was adopted from a research collaboration of Worldline and the Machine Learning Group of the Free University of Brussels. We explored the data to find any meaningful information found within the patterns, source, data relations, format, and metadata. Now, we found that the feature time was not significant to the overall model and removed it from our dataset during our data cleansing process. And once removed, we saw a correlative increase in our measuring metrics: accuracy, precision, recall, and later area under the ROC curve. The dataset is also highly imbalanced. The amount of fraudulent activity accounted for less than 1%, or 0.172%, of all the recorded transactions. And lastly, we know that any developed model must beat the class majority classifier of 99.82%. We start our solution methodology with its foundation, the model considerations. The Branson Tourism Center and their application, Branson on the Web, support a consumer-focused mentality. The Branson Tourism Center has a focus on achieving a high level of consumer satisfaction, and their web application, Branson on the Web, is attempting to make significant improvements towards their credit card fraud detection process. Additionally, we developed the model with an emphasis on lowering the prediction false negatives over the false positives in the model's output. This is directly tied to the Branson Tourism Center's focus on achieving a high level of customer satisfaction. Now, we determined that a false negative, a denied legitimate transaction, would be far more detrimental to the consumer than a false positive, or an allowed fraudulent transaction, for which the credit card companies typically insure and refund against. And lastly, our group's machine learning solution falls within the classification family of models. Now, we rationalize the use of a classification model through its primary characteristics of predicting class labels as an output. More specifically, this fraud case deals in zeros and ones, or legitimate transactions, and fraudulent transactions. And we know that this aligns perfectly with the binary classifier, where the system restricts to one of two output classes. As with our competitors, we used an iterative process to develop our solution. Now, if you remember from a few slides ago, we determined that any model that we build would have to beat the majority class classifier, or 99.83% accuracy, in order to be deemed a better solution than what was already presented by our data. As part of our iterative process, we first had to develop a baseline model, which we determined would be the most simplest classifier that we could discover, or the logistic classifier. Now, this classifier ended up returning an accuracy of 99.90% accuracy. And our final solution is a boosted trees classifier. This was our best model determined, which returned an accuracy of 99.96%, or translated, it's 3.69 fraudulent transactions will remain undetected for every 10,000 transactions. Our second metric in determining our best model is our area under the curve, or in this case, area under the ROC curve. Our baseline model, our logistic classifier, received a score of 0.9799, and our best model, boosted trees classifier, to compare, received a 0.9861. And if you take a closer look at the actual curves, you can see that the boosted trees model has a much steeper rate than the logistic model displayed on the left. Our third and final metric in determining our best model is the false negative and false positive rates. Now, if you remember back to our model considerations, Branson Tourism Center and the Branson on the Web app are trying to build their customer satisfaction. Therefore, we optimize our model to increasingly deliver a lower false negative rate. And as you can see from our summary and our model confusion matrices on this page, is that our false negative score received the best under our majority class classifier, however received a very low score under the boosted trees classifier. In this instance, the lower is better. On false positives, our boosted trees classifier received the lowest score. This table depicts our overall model scoring. So as you can see, we have our four metrics on the left-hand side of the table, and then each of the models listed across the top. So you can see that our majority class classifier performed the poorest, followed by our baseline model, our logistic classifier with 7 total points, and lastly, our best model outperformed the other two with 11 total points. We found that the gradient boosted regression trees was the best classifier to use given its effectiveness as a machine learning tool, use in predictive analytics, and it's scoring the highest across our metrics. The boosted trees model makes its prediction through combining decisions from a sequence of base models, or trees. The model uses ensembling to take each weaker base decision tree and builds the model in a successive sequence while concurrently generalizing the model through optimization of the cost associated with each event. In our example of classification, the gradient reflects a representation of minimizing the loss function over our entire training set. Now, this model was deemed the best, again, because it performed the highest across our predetermined metrics. As mentioned previously, it is outside the scope of this project to implement a recommended solution. However, upon contract, a follow-up implementation project can be created to do just that. Now, this project would include the implementation of the recommended technology, specifically its use at the point of online sale, and it would assist your organization in determining the fraudulent activity based on credit card PCA values, and it could detect fraud with a 99.96 accuracy. In addition, we would develop a maintenance and training support plan for use at your organization. However, it could also be applied across the other Branson Strip organizations. And lastly, we could provide any technical assistance throughout the life of this contract. As you revealed to us during the initial stages of the project, last year there were 43,920 shows in Branson, Missouri, with 87,840 tickets sold online. Now, of those online purchases, there were 75 cases of detected fraud, or 1 in 1,200 transactions, costing your organization an expense of $18,300 in fraudulent claims. Now, these levels have exceeded the industry norm and are on par with 1999's fraud detection levels. If the Branson on the Web application modernized their fraud detection systems through adopting our solution, a minimum of $18,117 in fraudulent charges could be saved per year. Now, this is a modest estimate using a baseline 99% accuracy rate. In addition, you can decrease your card processing fees due to a lower risk of processed fraudulent charges being claimed through your credit lending institution. In addition, you'll be able to increase your satisfaction and trust through restoring your image as a trusted online merchant. And lastly, through adopting our solution, you'll be able to reduce your overall personnel costs by decreasing your consumer protection personnel on staff.
Thank you, Joshua, for going over our credit card fraud model and the reasons why you should use our model going forward. In addition to utilizing our credit card fraud model, there are additional areas that you could extend machine learning, and we could help provide these machine learning applications, training, and analytical services that you could then sell to your clients that are utilizing your platform. One of these areas would be in marketing, and using a linear regression model, we would provide a measurable foundation that could help you decide which new market opportunities to pursue and where you should be directing your expenditures, such as which advertising channels you should be using. Another area that we could help with using linear regression would be to answer the questions, when are employees and costs needed the most? So this would be answering a staffing question. And the last application that we would be using linear regression for would be for determining future revenue or ticket sales, and this would use a clustering and linear regression model, and we would be able to identify what consumers to target, how to reach them, when to make contact, and what messages should we be communicating to them to gain their business.
So to continue where Ashley left off, another area that could be improved is locations. And you can use a clustering model to help answer the question is where is the best location to conduct a show. It could give a local, regional, and even international areas that people may be interested in the same performances that appear on the Branson Strip. Clustering could also help in giving the best prices that tickets are ensured to sell out, which would be based on the type of performance. Also, another good tool to use would be classification, and this could be used in helping to find the audience type that would typically attend your performances. This could also bring about a new audience sector that you hadn't even thought about. And last, sentiment analysis could be used in discovering popular trends in the performance. For instance, finding out what material in your performances have positive sentiments, and then using this information to create new shows around these positive sentiments that will attract its intended audience.
Pending any questions, this concludes our presentation.